Hello everyone, myself I am Divya from Department Chemistry and I am working as Assistant Professor in Marri Laxman Reddy Institute of Technology and Management. Okay, so today we are going to discuss a topic known as battery chemistry. It is a module 2 from engineering chemistry subject. Okay, so today we are going to discuss some topics from the battery chemistry, that is introduction and the classification of batteries, that is primary battery and secondary battery, and also we are going to discuss the construction, working and applications of. So first of all, what do you mean by a battery? So battery is a device. It is a electrochemical device. It converts the chemical energy into a electrical energy. So you can see a diagram here on the screen. So a electrochemical device consists of two electrodes. One is anode and the other one is cathode. Okay, so it consists of two electrodes. One is anode and the other one is cathode, and we dip these electrodes in the electrolyte solution. Okay, and these electrolyte solutions are connected through a salt bridge. These are connected through a salt bridge. So what is the use of salt bridge? It will allow the passage of ions from one electrode to the another electrode. So through the salt bridge, the ions move from one electrode to another electrode, and also the electrodes are connected to a voltmeter or galvanometer. Okay, these electrodes are connected to the voltmeter, and from this electrons flow from anode to cathode. Okay, and here also the anode is stripped. Here we see anode as a zinc, as we are taking here anode as a zinc metal and here cathode as a copper metal. Okay, this is a basic introduction for the electrochemical cell or device. Okay, next, what are batteries? So batteries are the two or more electrochemical cells are electrically interconnected in a series that can be used as a batteries. Okay, next, these act as a portable source of electrical energy. Okay, and major classification of batteries are classified into two types. One is primary battery and the other one is secondary battery. Okay, one is primary battery and the other one is secondary battery. Now we'll see the definitions of primary battery and also the secondary battery. Okay, so coming to the primary battery, so primary battery cells are also known as non-rechargeable battery. Okay, it is a non-rechargeable. So in simple term, we can say these batteries are for single term use, like a single use. Okay, next, second type of battery, that is secondary battery. It is a rechargeable battery. So the major difference between the primary battery and the secondary battery is primary battery, here it is a non-rechargeable, like we use in our torch lights. Okay, and the secondary battery example is like a lithium ion batteries which we use in our laptops, phones, etc. Okay, next, coming to the primary batteries. So as we have discussed earlier, it is a non-rechargeable battery. Primary battery is a non-rechargeable battery and it is a single use. That means once we use a battery, if cell gets exhausted, we have to throw it. It cannot be used again. Okay, next, this cell reaction here is not reversible. Okay, cell reaction is not reversible and it is also less expensive, and as we have said earlier, it is used in gadgets like torchlights, watches and toys. Okay, these are the examples for the primary battery. Okay, next, these are source of DC power like direct current. Okay, so examples of the primary batteries are like dry cell and zinc air batteries. So these are some of the points for the primary batteries. Firstly, mainly it is a non-rechargeable battery. Okay, so we are going to discuss a most common example of a primary battery, that is zinc air battery, in detail. So we'll see the construction, working and applications of zinc air battery. Okay, so first coming to the zinc air battery construction, as we have seen earlier, like in any device like a cell or a battery, it will be consisting of three major components, that are one is anode, second one is cathode, and the other one is electrolyte. In any cell or any device like battery, if you take, you are going to see these three major things mainly. Okay, anode, cathode and electrolyte. So coming to our now topic, zinc air battery, here we use anode as a zinc metal. What we use here is a zinc metal. Okay, and second we are going to use as a cathode, that is oxygen. What? Oxygen. As the name indicates here, zinc air. Okay, air is nothing but here we take as a oxygen that enters from the cathode. Okay, now the anode is made by a zinc metal and cathode is made by a porous carbon plate. Okay, porous carbon plate. We'll see what do you mean by a porous carbon plate. Next here we are going to see, as I said, anode, cathode, right, and the other one is electrolyte. What is it? Electrolyte. So here we use a electrolyte, that is potassium hydroxide. What? Potassium hydroxide. Okay, one more thing, the zinc air battery, we also call it as alkaline battery. Why? Because in zinc air battery we use the electrolyte solution is a alkaline solution. So we may take it as a KOH or NOH. Either it may be, we can use like potassium hydroxide we can use, otherwise sodium hydroxide we use. But here we are taking potassium hydroxide because the ionic conductance of the potassium hydroxide is more compared to the sodium hydroxide. Understood? So a zinc air battery, we are having two electrodes, one is anode and the other one is cathode. So anode is made by zinc metal and the cathode is made by porous carbon plate, through which it allows the passage of oxygen to the cell. Okay, here you can see here porous carbon plate. Okay, now these two electrodes are separated by a separator. What? Separator. Here you can see a green plate, right? It is called as separator. Okay, so as I said, anode containing a zinc and it is mixed with the 20% of KOH electrolyte, and the cathode, as we have discussed, it is made by a porous carbon plate. Okay, so if you see the diagram, see the down part is nothing but your cathode. Okay, it is a porous carbon plate, and the above part is a zinc granules. Okay, zinc granules, and this anode and cathode are like encapsulated in the insulator gasket. Okay, so it will allow only the passage of oxygen and it will prevent the passage of moisture to the cell. Okay, next, coming to the cell reactions as follows. At anode we see the oxidation reaction. At anode zinc is there and zinc undergo the oxidation reaction. Okay, hence it is liberating two electrons which are consumed by cathode. Okay, so at cathode we have oxygen, it is undergoing reduction reaction. Okay, it is undergoing reduction reaction. So overall reaction, it is producing zinc hydroxide as a product. Okay, this is nothing but your construction and working of the zinc air battery. So coming to the applications of zinc air battery, the one of the most majorly used zinc air batteries is like hearing aids. Okay, we use in hearing aids. Can you see the picture here? Okay, and this cells, like in this devices, we use a battery that is zinc air battery. Okay, and also it is used in the power pack for the mobile phones and also in the military radio receivers and also in the voice transmitters. So these are some of the applications of zinc air battery. So next, coming to the advantages of zinc air battery, the advantages of zinc air battery are safety and environmental benefits, like because it is having a good shelf life and also we are getting it low cost. Okay. Next, in addition, it is also having a high energy density. It is having a high energy density compared to most of primary batteries. We also have other type of primary batteries. So compared to those primary batteries, our zinc air battery is having high energy density. Okay. Next, it is incredibly safe and are highly not highly reactive or flammable. Okay. So, and because of this, it is like free from toxic compounds. Free from toxic compounds. These are the advantages of zinc air battery. So we have seen the zinc air battery construction, working and applications. Okay. So next we move to the other type of battery, that is a secondary battery. Okay, that is a secondary battery. So here it is a quite opposite for the primary battery. As we have studied in primary battery, it is a non-rechargeable battery and it is used for only single time. Okay, so but now the secondary battery is a rechargeable battery and we can use it for multiple times. As example is one of most example is our mobile phones. Okay, the batteries which we use in our mobile phones are made of from this secondary battery. Okay, as we charge multiple times, right? So secondary batteries we can charge multiple times. Okay, so these are rechargeable batteries and designed to be recharged and used multiple times. Okay, and here the cell reaction is reversible. Here the cell reaction is reversible. Next, and here the secondary batteries can be used through a large number of cycles of discharging and charging. When we go deep into this topic, we are going to understand what do you mean by like charging and discharging. Okay, next, these batteries have a large capacitance. Okay, next, cell reaction is what? Reversible. Okay, as it is a rechargeable batteries, the cell reaction is reversible, and it most common examples for secondary batteries are lithium ion battery, lithium ion cell or lithium ion battery, and also the lead acid or the nickel cadmium cell. Okay, so this is about the secondary cell. Okay, now we are going to discuss a type of cell, that is lithium ion cell. Okay, lithium ion cell. So as it comes under secondary battery, it is a rechargeable battery. It is a rechargeable battery. Next, a lithium ion battery, again as every cell, it also consisting of two electrodes. What? Two electrodes. One is anode and the other one is cathode. Can you see the picture here? See here, this one is anode and this is the cathode. Okay, and these two electrodes are again separated by a separator. It is separated by a separator. Okay, now we'll see what is anode here, what is cathode here. Okay, now the anode is made by, see, copper, made by copper foil. Okay, copper foil. Next, here cathode is made by aluminium. Cathode is made by aluminium. Okay, now what is their anode? Okay, what is anode here? Now here anode we are taking as a lithium doped graphite. Lithium doped graphite. That means we are going to have a graphite sheet on which a lithium is doped. Okay, on which a lithium is doped. That is anode. Next, coming to the cathode, here a cathode is a lithium cobalt oxide. Okay, metal oxides we are going to use as a cathode here. So that is nothing but lithium cobalt oxide. So this is your cathode, this is your cathode and this is your anode, and these two are separated by a separator. Okay, now as we know separator, what is the use of this separator? It will allow the passage of ions from anode to cathode, as it is a reversible again from cathode to anode. Okay, so we have understood what is anode here. cathode, and the electrolyte solution is nothing but a lithium compounds dissolved in organic solvents. We take a electrolyte solution, that is lithium compounds dissolved in organic solvents. Okay, so under lithium ion battery or secondary battery, we are going to have one more, is that nothing but charging and discharging. Okay, as we have seen earlier, in secondary batteries, these can be used through the large number of cycles of charging and discharging. Now we'll see what do you mean by charging and discharging. So charging, near charging, what is happening is, during the charging, the lithium ions flow from cathode to anode, So we have anode here, we have cathode here, yes, and here is electrolyte solution. Okay, so during charging process, as a mobile phone charging, okay, during this process, the lithium ions, what are the ions here? Lithium ions will move from cathode to anode. See, cathode to anode. The ions direction will be like this, cathode to anode. And you can see here the picture also. Okay, this is the anode and this is your cathode. So what we are saying, during charging process, the lithium ions present in the cathode, will be moving from cathode to anode through the separator, through the electrolyte solution. Okay, this is about the charging. So you can see a charge, like how lithium ion batteries work during charging. So these are your cathode and this is your anode. Okay, this is your cathode, this is your anode. Okay, so as we said, charging means ions move from cathode to anode. Okay, next, you can see the video here, how lithium ions are moving from cathode to anode and the electrons from the circuit. Okay, next we have is discharging. What? Discharging. So during discharging, the lithium ions will come back. That means from anode to cathode. So simple difference between this charging and discharging. During charging process, remember, the ions are moving from cathode to anode. This is for charging. Okay, during discharging, the ions are moving from anode to cathode. Okay, so cell reactions during discharging. So what is happening? These lithium ions are flowing back when you're discharging, or when a device, like when your mobile phone or laptop is working, then at that time discharging is occurring. Okay, that means the ions are flowing back to its original. Okay, so anode to cathode. See, so this is your anode, this is your cathode, how lithium ions are moving back. Okay, anode to cathode and electrons from the circuit. Okay, so overall reaction we get here is as follows. And next, at cathode, what is there? Lithium cobalt oxide. It will consume the lithium ions and also the electrons liberated from the anode, and it gives the lithium cobalt oxide. Okay, and at anode, what is there? Lithium doped graphite. It liberates the electrons. Okay, so it's like a final image, like you can see a simple way to understand charge and discharge. As we know, we have a anode and cathode. Okay, so here I represents as a current. That means a current is flowing from during charging process. Okay, during charging process, current is flowing from where? Positive to negative. Okay, coming to the discharge, current is flowing from where? Negative to positive. Okay, and you have understood like what is the direction of lithium ions also. Coming to the charging and discharging. Okay. Now coming to the applications of lithium ion battery. Okay, it is having a vast applications in the like today's thing. Okay, now first application is like we are going to use these, like we are using, okay, we are using this lithium ion batteries in our cell phones, mobile phones, sorry, laptops, okay, TVs. Okay, next, and also it is used in calculators, okay, scientific calculators, and also it is used in medical field like cardiac pacemakers. Okay, so these are the applications of lithium ion battery. Coming to the advantages, lithium ion batteries are having high voltage. Okay, like we have studied previous, that is primary battery, its voltage is somewhat around 2 or 1.3. It's a voltage of primary battery. But coming to the secondary battery, it is having more voltage or high voltage. Okay, so it is a major advantage of a secondary battery. Okay, and also it is a lightweight batteries. Okay, it is a lightweight batteries. And also one more advantage of lithium ion battery is a smaller in size. Okay, smaller in size. And also coming to the lithium ion battery, it produces 3 times voltage. Okay, it is a triple, okay, 3 times voltage of nickel cadmium batteries. Okay, these are the advantages, and also these are applications of lithium ion batteries. I hope you have understood today's session. Okay, we have discussed what is a battery. Okay, battery is classified into 2 types, that is primary battery and secondary battery. So under primary battery, we have studied zinc air battery. So we have seen its construction working, and next we have studied is secondary battery. Under secondary battery example we have studied is lithium ion battery. Okay.